This section explains how the meaning of a sentence reduces to a single computational shape. To mean a sentence is to know what the world must be like for it to hold. Meaning simply is truth, conditions, the partition of all possible situations into the true side and the false side. But you understand sentences you have never heard before, so this partition cannot be stored anywhere. It must be computed from parts. Frege's move supplies the engine. Take the sentence, Caesar conquered Gaul, and split it into two kinds of piece. One piece is saturated, the name. The other is unsaturated, the predicate, which contains an empty place. And that unsaturated piece is a function. Composition is then nothing but application. You feed the argument to the function, and saturation completes the sense, so the entire program compresses to one shape. A sentence's meaning is a function. Application tree that bottoms out in a truth condition. This section explains what it means to know a sentence, and the one identification that a whole book unfolds from. To know a sentence is to know what the world must be like for it to be true. Meaning is truth conditions. The step that does the real work lies elsewhere. Tarski's snow is white. Schema looks banal on its own. What matters is that you grasp sentences you have never heard, so truth conditions must be computed from parts. Frege supplies the composition law. Take the sentence, Caesar conquered Gaul, and split it into a saturated part, the name, and an unsaturated one, conquered Gaul, which carries an empty place. Then identify the unsaturated meaning with a function, and saturation with function application. That single identification, unsaturated equals function, is the generative seed. The whole book is its unfolding, so the chapter closes on sets and functions, the algebra. Everything downstream will run on. This section explains how Frege's conjecture becomes a working machine. Frege's conjecture that all semantic composition is functional application stops being a philosophical claim and turns into a machine you can run. The move is to fix three parts. First, an inventory of denotations, individuals, truth values, and functions between them. Second, a lexicon assigning each word. One of those denotations. Feed in a syntax tree, and the truth conditions fall out. Provable, line by line. Here is the surprise that makes the whole thing go. Saturation does the typing. Sentences and names are saturated, so an intransitive verb must denote a function from individuals to truth values. The composition rule forces the lexical entry. The meaning of the whole is nothing but application climbing the tree. This section explains how the whole semantic machine collapses to a single move. That move is this. Denotation composes by functional application, driven by the syntax tree. A name denotes its bearer, and that denotation is saturated. An intransitive verb denotes a function from individuals to the set containing 0 and 1, and that denotation is unsaturated. A branching node's value is just the one daughter's function applied to the other daughter's argument. That is Frege's conjecture, the chapter's central bet. The application is the only composition rule you ever need. Everything else in the system is downstream of this one commitment. Sentences denote truth values. Yet, because the interpretation function, written as double brackets around an expression, builds each tree's value from its parts, truth conditions fall out for free. Chapter 1. Stated the goal. Here, Frige's program becomes a running fragment of English in 3 parts: the denotation inventory, the lexicon, and the node rules. This section explains Frige's conjecture and what it does to the machinery of meaning. The conjecture says that all non-trivial composition is functional application. That single claim collapses a grammar that once needed a separate rule for every construction into just 3 type-blind principles: terminal lookup, non-branching pass-through, and application. Meaning stops living in the rules and moves entirely into the lexicon. The mother node's value is then forced because only one daughter can be a function whose domain holds the other. The types select the operation, so linear order and category labels go invisible to interpretation. This makes the interpretation function partial, defined only where the types fit. That partiality severs semantic interpretability from syntactic well-formedness. A tree can be perfectly grammatical yet carry no denotation, and the reverse holds just as well. Here is the payload. Composition is emergent from the types of the parts, arising from them rather than stipulated structure by structure. This section explains Frige's conjecture and how it reduces semantic interpretation to a single rule. Frige's conjecture says that all non-trivial composition is functional application, that one claim collapses the grammar's tangle of construction, specific interpretation rules down to 3, read a leaf's meaning from the lexicon, pass it unchanged through a node that does not branch, and at every branch apply whichever daughter is a function to the other. Which daughter is the function and which is the argument is never stipulated. The types decide. Only one assignment lets a domain contain the other, so the choice is forced, not declared. This means a tree's meaning is fixed by lexical denotations plus bare dominance alone. Syntactic category labels and linear order go invisible to the semantics. You specify the words, and the rest computes itself. The interpreter stops being a case table and becomes a single typed dispatch. This section explains how the fragment covers nouns, adjectives, and prepositions without adding new denotational machinery. A predicate is a set, a characteristic function of type E, T. Once you see that, nouns, adjectives, and prepositions stop being new categories. Dog, gray, and in Vienna all denote the same shape the verb already did, so the fragment grows without any new denotational machinery. Only 2 gears are added. The first gear is predicate modification, when functional application cannot fire because 2 sister nodes, both of type E, T, each want an argument, you combine them by pointwise conjunction. Gray dog is the intersection of the grays and the dogs. The second gear is the word the, which becomes iota, the partial function returning the unique satisfier. When there is no unique satisfier, when the set is empty or has more than one member, the result is undefinedness, presupposition failure, rather than falsity. The thesis is that coverage expands while the primitives do not. Intersection and uniqueness are the whole new budget. This part explains how one composition rule stops being enough. The engine so far runs on 2 saturated types and one rule, functional application, which fires whenever one sister's type is the argument of the others. Chapter 4 drives that engine into more of English and finds where it stalls. Take the phrase city in Texas. Here, 2 sisters are both of type ET, and neither is the argument of the other. So functional application deadlocks. The repair is minimal and diagnostic. Add predicate modification. the pointwise conjunction of the two characteristic functions, that is, set intersection. The primitive to carry is this. Composition rules are never posited freely. Each is the least addition that dissolves one specific type clash. Argument taking reduces a predicate's adicity, modification preserves it, and which operation applies is forced by the types, not chosen. This section explains how a relative clause fills a gap. It cannot fill directly, using variables and variable binding. A relative clause needs its gap, as in the car which I bought trace, to denote an individual so the embedded sentence composes. Yet no individual is available to fill it. Heim and Kratzer's move is to stop demanding a fixed denotation. The trace denotes only relative to an assignment, a parameter supplied from outside. Meaning becomes a function of that parameter, and every rule above the trace inherits the dependence. Binding is the inverse. The relative operator quantifies the parameter away, collapsing an assignment, dependent open sentence back into an ordinary set, denoting modifier. That is the whole primitive, reference deferred to a parameter, then abstracted over. It is the same free variable closed by abstraction shape as the lambda calculus. This section explains why a relative clause, simple as it looks, breaks the machine that builds meaning from parts. A relative clause is just an intersective modifier. It has the same type as an adjective, the type from entities to truth values. Yet computing it compositionally breaks the machine. The trace inside it has no local referent that any subtree can supply. Letting it inherit its value from the whole determiner phrase is viciously circular because the whole is supposed to be built from the parts. The chapter's move is this. When a part has no denotation of its own, relativize its meaning to an external parameter, an assignment. Now the trace denotes only under a choice, and every phrase above it becomes a function of that choice. Binding then re-internalizes the parameter higher up. The generative primitive is that a whole composition cannot fill locally, forces meaning to become a function of an environment. This section explains why a quantifier, like every student, has a different semantic type from an ordinary name. A name feeds an individual to a predicate, but every student names no individual, so it cannot occupy that slot. The chapter's single move is this: type mismatch forces role reversal. A typey subject is the argument that a predicate consumes. A quantificational determiner phrase works the other way around. It is the function that comma t, comma t, comma t takes the verb phrase's set, whose type is e comma t, a function from entities to truth values, and it returns a truth values. So its own type is one level up, a function from an e comma t set to a truth value, written e comma t set to a truth value, written e. The determiner every is one level higher still, relating two such sets. The primitive you carry away is this: semantic type dictates who applies to whom. Once a phrase cannot denote an entity, composition has only one direction left. You climb the type hierarchy until application type checks. This section explains why a quantifier phrase names no object. A quantifier phrase denotes no thing. Fix three things, the predicate at the type, from entities to truth values, written E to T, that is, a TP, a bare truth value, a bare truth value, and functional application as the only glue. Then the subject slot is forced. Whatever fills, it must consume the predicate and return a truth value. Hence, its type runs from E to T, up to T, up to T, within E to T, up to T. That is, it takes a property and returns a truth value. This inverts the naive picture where the predicate eats its subject. Here, the word nothing eats the word vanished. The argument against individuals is diagnostic. A name validates three inferences: subset to superset, contradiction, and excluded middle. The phrase, at most, one letter breaks all three, so it cannot be a name. A DP is thus a test on properties, a second-order property, a generalized quantifier, not a member of the domain. This first part explains why a quantifier does not fit the object position and what grammar does to repair it. A quantifier is the wrong shape for the slot it wants. The phrase every linguist denotes a property of sets, the typewritten double bracket et, t, that is fine as a subject, where it takes the verb phrase as its argument. It is fatal in object position, where it takes the verb phrase as its argument. It is fatal in object permands an individual. Grammar's repair is displacement. Raise the quantifier, leave a trace of type E in the vacated slot, and let predicate abstraction over its index rebuild the remainder as a predicate the quantifier can bind. Quantification simply is taking scope. It is the same trace in abstraction machinery that Chapter 5 built for relative clauses, now revealed as the general mechanism, and English determiners are irreducibly two-place relations on sets. Predicate logic's one-place sentence operators are the wrong model. The word most is the witness that cannot be paraphrased away. This section explains why a level called logical form has to exist at all, and it starts from a mismatch in semantic types. A quantifier phrase carries the type written E to T to T. It wants a one-place predicate to consume. In subject position, it finds one. In object position, the transitive verb offers only the type E to T, and composition stalls. The chapter's whole work is that this stall is a well-formed misfilter, something you honor rather than root around. It admits exactly two repairs. The first is to make the rigid operator flexible, either make it polymorphic or type-shift the determiner in place. The second is to move the tree into a shape the rigid operator already fits. That second repair is covert raising. It drops an index trace and a binder, feeding interpretation but not pronunciation, and it is why logical form exists. Semantics is what forces the level into being. The syntax only carries it. This section explains why every constraint on quantifier movement splits into two independent filters, and why the chapter's whole method is a refusal to stipulate what one of those filters already forces. The first filter is semantic, and its name is interpretability. A quantifier of type ET to T can only land where its sister composes to a truth, value. So the rule adjoined to a node of type T costs nothing to posit because the composition rules already demand it. The second filter is syntactic, and its name is locality. A quantifier raised out of a relative clause composes perfectly, yet the sentence is dead. Interpretability is silent there. So the island constraint is irreducibly syntactic. The generative move follows from this. For any observed restriction on movement, ask which module already forces it and stipulate only the residue. This first section explains how the rules for quantifier movement stop being a stipulation and become a theorem. May stipulated where quantifiers move, they adjoin to S and they target the feature Q. This chapter dissolves that stipulation into a theorem. Quantifier movement is fixed by two independent forces, the general laws of syntax and the demands of interpretability, with nothing proprietary to quantifiers at all. Here is the mechanism. Grant only the minimal inventory, functional application, predicate modification, predicate abstraction, and no type shifting. A raised quantifier has a type that takes a predicate of type ET and returns a truth value, the type written as ET, T. Given that inventory, such a quantifier can only land where its sister is type T, T. Given that inventory, such a quantifier can only land where its sister. So the landing sites are not a syntactic list to memorize. They are wherever a type T node sits, whether that is S, BP, PP, NP, or DP, once you grant those nodes the right internal structure. The constraint you would otherwise have to posit falls out of what the semantics can compose. This section explains why the strict versus sloppy ambiguity of ellipsis is not really about ellipsis at all. Every pronoun carries a latent fork. It can denote a fixed individual, free and referential, or it can covary with a quantifier that binds it. Chapter 5. Supplied only the bound reading. Here the free one arrives, and with it the payoff. The notorious strict versus sloppy ambiguity of ellipsis belongs to the pronoun, not to the ellipsis. When we say Marcel didn't, that elided clause inherits whatever reading the pronoun has already had in the antecedent. It is strict when the pronoun was referential and sloppy when the pronoun was referential and sloppy when the pronoun was bound. Copy a verb phrase under the LF, identity condition, and you copy its fork intact. The elided clause has no freedom. The overt one lacked. The chapter's move is reduction. A mysterious downstream ambiguity dissolves into a known upstream one, with ellipsis contributing only faithful duplication. This section explains where the strict versus sloppy split in ellipsis actually comes from. That split is the bound versus free ambiguity of the pronoun, made visible ambiguity. Every pronoun already carries two construals, a bound variable, co-indexed to a raised antecedent, or a free variable, whose referent the utterance context supplies. In a single sentence, these two logical forms collapse to identical truth conditions, an invisible ambiguity. Ellipsis is the developer. The logical form identity condition copies whichever logical form the antecedent had, so the copy inherits that choice. And the two construals now diverge downstream, strict from the free copy, sloppy from the bound. There is no new mechanism here. It is a latent distinction forced into observability by an operation that must preserve ability, by an operation that must preserve ability, by an operation that must preserve it. This section separates two relations that wear a single name, binding. Syntactic binding is a configuration. It is co-indexing under C command, a fact about the tree. Semantic binding is functional dependence. The binder's denotation genuinely covaries with the variable it closes, and this is delivered by predicate abstraction, which converts an assignment relative value into a bound 1. The chapter's move is to define this second relation precisely and to show that semantic binding, rather than co-indexing, carries the interpretive load. The two can come apart. An antecedent may, C, command another position and share an index with it, yet still fail to semantically bind it, because no lambda actually abstracts over that position, meaning tracks the abstraction operator, not the diacritic. The index is bookkeeping. The binding is what the operator does. This section explains how two separate ideas of binding get welded into one. Two notions of binding that had no reason to coincide get joined by a single biconditional. A pronoun is syntactically bound at surface structure C, commanded by a co-indexed antecedent exactly when it reads as a bound variable at logical form. The force of this is that it makes quantifier raising obligatory even where no type mismatch demands it. The sentence, "Every diver defended himself," can mean nothing else because the reflexive must be bound, so the quantifier must raise. The surprise underneath is that co-reference lives nowhere in the grammar. Binding theory never mentions reference. It constrains only variable binding. What looks like a rule about who refers to whom is a rule about tree geometry, and reference falls out pragmatically. This part explains E-type anaphora, a way a pronoun can find its meaning when the usual mechanism fails. A pronoun sometimes reaches its antecedent without being bound by it. Take the sentence, "Every farmer who owns a donkey beats it." The worded sits outside the quantifier's grasp, yet it still lands on the right donkey. The E-type move is this. The pronoun silently rebuilds a definite description out of its own antecedent clause, the donkey he owns, and it denotes through that description rather than as a bound variable. Binding is the mechanism you expect. Where binding cannot reach, description recovers the reference instead. The generative pattern to keep is this. An anaphor can mean by reconstructing a description, not only by sharing a variable. That single fork covers every donkey sentence you will meet. This section explains the E-type pronoun, the third species of pronoun in Heim and Kreuzer's chapter. Some pronouns cannot point at anything and cannot be bound by any quantifier standing above them, yet they clearly lean on a quantifier that came before. Heim and Kreuzer's answer is a third species of pronoun, the E-type pronoun, and the whole chapter is one move. Read such a pronoun as a hidden definite description, the such and such, whose describing predicate is silent and recovered from the previous sentence. Take the text. Only one congressman admires Kennedy. He is very junior. Here, the word he means the congressman who admires Kennedy. That single rereading, a pronoun as a disguised the, is the generative primitive. Beat it any quantifier and it regenerates the entire zoo of hard cases, donkey sentences, and paycheck sentences alike. This section explains what the chapter on intentional semantics is for. Extensional semantics fixes every expression's value at the actual world, and that fixing breaks the moment a sentence reasons about how things might have been. The first step is to stop asking what an expression denotes and start asking what it denotes at a world. Every meaning becomes a function from possible worlds to its old extension, and that function is the intention. A word like must, or believe, or might is precisely one that reads the whole function rather than its value at the here and now. Truth at a point becomes truth across a space of points. This layer explains the single move the chapter turns on. Extensional meaning collapses whenever a word like believes sits between you and a sentence. Two sentences that happen to share a truth value become substitutable, yet Mary can believe one and not the other. The repair is a lift. Where meaning was a value at the actual world, it becomes a function from possible worlds to values. Frege's sense, made precise by Carnap, is exactly this function. Here is the primitive to carry forward. When a single point fails to separate cases you must keep apart, promote it to the whole curve it was one point of.